Thank you very much for joining today's online event about virtualization of applications in digital substations. I'm here today together with my colleague Jan Hille, who is Solution Architect at Velotech, and myself, Jost Zenner, CTO at Velotech. Today, we'd like to talk about applications in substations and how to virtualize them on a server and utilize the advantages of this, increasing reliability and reducing cost. Let's have a look at the agenda. Very important, at the end, we have a 15-minute session for questions and answers. So please feel free to ask questions at any time during the event. There is a Q&A box within the Zoom app, or just use the chat function to write your questions. The event will take around 30 minutes, and we are talking about what is virtualization, what kind of business implications you have, then that you need hypervisors for virtualization and what kind of different hypervisors there are, how to manage virtual machines. There is the possibility of central and local management. And then we go into a few examples and appliances that can be virtualized for substation automation, but also for OT security within substations. So what is virtualization and why do we use it now in substation automation as well? The reason behind is pretty much simple. It was used for decades in data centers and in IT environments. And it was used because it reduced cost and it increased reliability. It makes it much easier to maintain systems. So it's a very proven system, and it was hardened over years, and it's reliable, and there are millions of installations worldwide. In substations, and especially in the energy sector, virtualization is not that common yet. The reason behind is, first of all, that servers that are rugged enough to meet the requirements of substations were not available, but they are now. So now we have computers or servers that are fast enough and powerful enough to run a hypervisor and multiple virtual machines, and at the same time that comply with IEC 61850-3 and IEEE 1613. Can also operate in minus temperatures and plus temperatures, so meeting the requirements of your secondary equipment within the substation. So looking at the typical substation layout, and here specifically at the station level, what you, for example, find is a substation automation system. You find the HMI, and you find power quality analysis. Usually you also have some kind of engineering workstation, operator workstation. And all those systems, even if they are looking different, are more or less computers. And computerized systems you can visualize. So the problem that we have at the moment is that you have many different boxes, many different types of hardware that are coming as appliance, just doing and fulfilling one function. If we are starting to virtualize, so this means bringing all those different appliances on one general multi-purpose computer hardware, like a standard computer or a standard server, you can reduce the number of devices that you have in a substation, and at the same time also the number of different types of hardware within a substation. So also hardware replacement and stock, and so it becomes much easier. Besides the typical substation functions like automation system, gateway, and so on, you can also virtualize IT and OT security solutions. So like firewall intrusion detection system, or some additional log server to log events, or even for physical security, video surveillance systems and key lock system and so on. So what kind of business implications you have? So with one single hardware that you are seeing on the left side, the three boxes on the bottom, the gray one, that are substation servers, and you can run multiple applications. So you can replace several bare metal boxes like the substation automation system, like the operating workstation, like engineering workstation, and firewall on a single hardware. If you want to keep it redundant, you can also add 2 hardwares. If you have more than 4 or 5 appliances running, you can also add a second server to run other appliances, depending on the functions you want to have. This will dramatically reduce operating costs because you have much less different hardware, and you can much better utilize the performance of the hardware. So the hardware itself becomes cheaper, and also operating becomes much cheaper. It's also easier to provision applications and resources. So if you want to add a new function to your substation, you don't have to install a new appliance inside. You can just install some software, which is very, very fast. In addition to that, it's very easy also to work on new OT security threats. Because new threats appear much more often than you update your full substation, because it's there for 20 years or 40 years. So you can just add an additional type of software for additional cybersecurity things. This will also allow you to increase the availability of the system, because you can also make backups very easy. So within one server or with external storage, you can store the image of the application. And if there is some issue, you can just run it on a second server or start a backup of the application or old version. So you can roll back and roll forward just with one click. And of course, in case you lose data, you can easily recover the data. Okay, Jan, now I will hand over to you that you explain a little bit about the basics of virtualization.
Yes, thank you very much, Heli. Hello, everybody, also from my side. What I would like to take a look on now is what virtualization really is, and how we can, of course, manage virtual machines and have a benefit out of that. So what is virtualization? In fact, in one sentence, virtualization is the process of running a virtual instance of a computer system in a layer abstracted from the actual hardware. What does it mean? So on the left side, you see a classic computer or server system, which you might have chosen according to your application. So you choose the processor and the storage and the memory according to what you really need for your application. Then you install the operating system on the server, and then you install your application or applications which you want to run on that. This is a classical computer. We all know that. Most probably we are all sitting in front of such a classic computer system. On the right side, you see maybe the same hardware, but we add an additional layer. We add a virtualization layer, which is installed directly on the hardware. And on top of this layer, we will be able to create virtual instances of computers. So this virtualization layer is taking care of managing the resources like CPU, RAM, storage, and interfaces for these virtual machines. And we will be able to assign smaller portions of these resources to each and every single virtual computer, which is built on top of this virtualization layer. This can, in fact, be one virtual computer or several virtual computers. Depends a little bit on the application's needs and also, of course, on the resources you have available on your server hardware. So these virtual computers are now pretty much handled like classic physical computers. You are installing your operating system inside, might be a Windows operating system or Linux operating system. And on top of that, you can install again your applications. The handling is pretty much the same as like a classical computer system. And also for the outside world, these computers really look like physical computers. Systems talking to them will not know that this is not a physical computer, it's a virtual computer system. Okay, so use the next slide, please. Now let's have a look on the different types of hypervisors. we already saw we need this kind of hypervisor to build up in these smaller virtual computer instances on top of the hardware. And in fact, there are two main different types of hypervisors. The type 1 hypervisor, which is also called bare metal hypervisor, you see it on the left side, and the type 2 hypervisor, which is called hosted hypervisor. The bare metal hypervisor is directly installed on the hardware. It's installed like an operating system. In fact, it is not really an operating system, but it is installed on the hardware like this operating system. And it has direct access to the hardware resources and can access it directly and share it with the virtual computers afterwards. Examples for type 1 hypervisors are, for example, VMware's vSphere or ESXi, as it has been called earlier, and also Microsoft's Hyper-V. Type 2 hypervisors are installed as an application on a host operating system. You can, for example, install VMware Workstation or the Parallels hypervisor on a classic operating system like Windows or iOS is also, or Apple OS, Mac OS, sorry, is also possible. This is then really an application running on your operating system, and this application is taking care of managing access to the resources. These type 2 hypervisors are mainly used for testing purposes. Type 1 hypervisors are really best suited for production environment, also for substation automation, because they have direct access to the hardware and therefore they are much more performant. Okay, next slide, please. We have, of course, a need to manage virtual machines. So we need some kind of interface and tools to manage, on the one side, the host system, the hypervisor itself, and of course, manage the virtual machines which are running inside this virtual environment. And all the different solutions have different tools and interfaces for that. VMware solution, for example, offers you a web UI on the host system, which is accessible using a browser. Microsoft's Hyper-V is offering a real application, which is running on Windows operating systems. And with these management tools, you can, in first step, manage such a virtual computer, in fact, like a classic physical computer. So you can assemble your computer using a CPU core or more than one CPU core, RAM, interfaces to the outside world, like building a classic physical computer using a screwdriver. But what you can, of course, do, there's management possibilities which go way beyond the possibilities of a classic physical computer. You can, for example, take snapshots of virtual computers. This is like a photography of the virtual computer's current state, where you can take a picture for smaller changes and roll back if the changes have not been working out. What you can also do, you can duplicate such a virtual computer. In fact, a virtual computer is nothing more or less than a set of files, and these set of files can be duplicated. For example, you want to build up a testing environment, which is really a copy of your production environment. Then you duplicate the whole environment, all the virtual computers, do your testing, and if successful, you can merge the changes back to the production system. And what of course, we are of course also able to export such a virtual computer. For example, we have built up a testing environment. We tested if everything works properly. We now want to roll this one out. Then we just export it and import it on other host systems where we want to operate this in the production environment. We have the possibilities in first step to build and manage a computer, assign resources to them, and on the other hand, act with this virtual computer as it is a file. We can copy it, we can backup it, import, export it. So very, very convenient for the production environment, also for testing. What's worth a look as well is the networking part in virtual environments. This is in fact special because we are able to build up virtual switches inside such a virtual environment. What does it mean? These virtual computers which are running inside such a virtual environment are in fact treated like classic physical appliances or computers. And you can assign also virtual network interfaces to these computers. These virtual network interfaces can then be assigned to virtual switches, which are also inside this virtual environment. And these virtual switches can then be used to attach these virtual machines to the outside world, to the physical network interfaces of the appliance itself. Why is this approach interesting? This means we may have the situation that those virtual machines inside such an environment have to communicate to each other, and this traffic does not leave this virtual environment. In fact, it does not cause any load on your physical network because it stays inside there. The other important thing is we can in fact secure the traffic between virtual computers and the outside world by, for example, adding a virtual firewall appliance, which is in front of the devices with regards to the real network interface. And we can control and manage the traffic, which is running from into this virtual environment. And also, even break it down to the single virtual machine, which is in fact a very, very high benefit with regards to security. It's in fact a real adding of a virtual security layer to this whole solution. Okay, next slide, please. These possibilities I just described are possibilities which are possible locally. So every host system offers such kind of an interface where you can manage and configure everything and set up the switches. And in fact, what you might need a central management for all of these devices, which really give you the possibility to monitor and manage a large number of those servers and also a large number of these virtual machines which are running inside the servers. So all the solutions bring kind of clustering solutions with them, allowing you to monitor and manage the virtual computers from a central point. And also, of course, the host systems. So in case of host system or virtual computers health problems, you will be able to get a notification, for example, in a SCADA system, or get an email notification. So there's a global monitoring system for this whole virtual environment, consisting of more than one server and a large number of virtual computers, in fact. What this also allows us is implementation of backup solutions. So we have the possibility to schedule, for example, regular backups and store them on some central service. And also bring up some high availability cluster, meaning that if one host system fails for any reason, for example, for network connectivity reasons or things like that, another host system will take over the virtual machines which are running on that. So in fact, quite a few options for disaster recovery and high availability features. Okay, next slide, please. You, of course, do not really have to use such a huge solution in the first place. Even virtualizing a single application or machine really makes sense because it gives you a lot of benefits. Let's give it an example. For example, you want to virtualize an HMI or a firewall system. This virtualization approach gives you the possibility for easy updates and, of course, rollbacks. Meaning, for example, you have to patch or update the operating system or the firewall's firmware or the HMI software solution. You will be able to duplicate your computer, for example, place the update, see if everything works. If yes, you can use this one as your production environment. If not, you can simply delete the one and roll back to the old solution. Or, for example, you can schedule backups, as I just said before. You see it also here in the picture. You can build up really a backup history of your operating system and the applications, the whole computer, in fact, meaning you can also build up schedule backups on a daily or weekly basis and roll back in case of any problems which pop up later or something like that. Another important point is taking snapshots. You might have a smaller change in your project, in your HMI environment. You just change it on the fly, check if everything works. If everything works as expected, you can just use the snapshot as production environment. If not, you can just roll back to the last snapshot. This is not really a backup. It's, as I said before, more like a photograph of the current state, which is stored in volatile memory of the host system or the virtual environment, which is then easily roll backable, and this is done very, very quickly, in fact. Another important point, maintenance purpose. You might bring up an intermediate device which can take up your operation. And in fact, do the maintenance on the system you need. And as soon as the maintenance is done, you bring up the production environment again, bring down this intermediate environment, which might be on some spare device, which is placed next to the installation or something like that. And then you are done. So you have a really reduced downtime. And the last and for example, most important point is hardware replacement. As we are able to export such a virtual computer or back it up and restore it, we are easily able to bring this specific virtual appliance onto a new hardware platform in a very, very short amount of time. So no new installation of the operating system and the application, no configuration is needed. You can just back up this appliance and restore it on another hardware platform, and it will work out of the box. This is just an example. This, of course, applies for several use cases. I also mentioned firewalls before. We see this for engineering workstations and many other appliances, in fact. Okay, back to yours.
Thank you, Jan. So I have two examples here how you can use virtualization with multiple machines. So you can take the Videotech 61850-3 substation server platform and run a hypervisor like a Hyper-V or VMware on it. And then for automation purposes, which is pretty common, you have HMI, you have the substation automation system and gateway, and the engineering workstation. So these three virtual machines are running on a single hardware. If you want to have it redundant, you can use two servers next to each other. And the redundancy is managed through the configuration of the hypervisors, which is more or less one click. So it's not very difficult to manage the redundancy. It's very, very easy. Those three virtual machines are then sharing CPU, RAM, disk, and network, but can also communicate through each other without using external interfaces, so just over internal switches, as Jan explained before. Another very interesting topic, and probably more interesting than the first one, is for IT and OT security. The reason behind it, it's more volatile. You need to change it more often because new IT and OT security threats appear. So, for example, if you're using a firewall on a substation server, and in 2 years you have the requirement to add intrusion detection system, and then you need to have probably another intrusion detection system, or you need to add a log server, you can just do it by software without installing new hardware. And this allows you to bring OT security into substations much faster and much more reliable. And also upgrading and maintaining of the virtual machines becomes much easier. You're also a little bit independent from the hardware that you have used before. So in terms of compatibility for updates and so on. So you replace hardware much less and you install less hardware. So what we see here is you can use these applications for automation purposes, but you can also use it for OT and IT security purposes. Another use case could be video surveillance, where you have a video surveillance system running on it, probably with some other physical entrance protection and so on. In addition to that, you can also combine those use cases. So you can also run the substation gateway together with a firewall on a single hardware. Great. So now we are at the end and we are ready for questions and answers. Before we start, just if one of your colleagues is interested, there is another session which will be on Friday with 8:30 a.m. European time. So in the morning here, probably at midnight in South America and North America. So most suitable for Europe and Southeast Asia and Middle East. So if you want to join, please feel free. And if you want your colleagues to join, just let them know and they can join at any time. Before we answer questions, please feel free to ask more. We will try to answer as many questions as possible here during the session. If we don't have enough time, we'll follow up with the questions afterwards with you, and one of our colleagues or we will directly get in contact with you. So Jan, do you have some questions for us already?
Yes, we have quite a few questions, in fact. Let's start with the question from Alexandra. She asks, can I run every application on a virtual computer, or are there limitations?
Okay, let me answer that. In general, every application that is running on an operating system or a standard operating system can be virtualized. And this is really done massively. So you can do it on a type 2 hypervisor and run it in your lab or even on your notebook, run those applications on different host operating system, but also on a bare metal type 1 hypervisor. There are some restrictions if it comes to real-time applications. So if you're thinking, for example, about protection and control, you would need to have a real-time hypervisor. There's, for example, the Helix platform from Wind River that can run with VxWorks. So there would be those possibilities. Not many applications are available for this operation yet, but we believe that it will be there in 2 to 3 years.
Okay, thank you very much. I would like to continue with, in fact, 2 questions. One is from Oleg. The other one is from Claudio. I think we might be able to answer these questions at once. They, in fact, fit a little bit to what you've been talking about now. Oleg wants to know, what do you think about the prospect of virtualization of secondary equipment, for example, meters, relay protection terminal? And Claudio is asking, are there already virtualized protection relays on the market?
There are some projects on the market that try to do real-time virtualization. It's in my understanding, it's not market ready yet. We are working on a next generation platform for next year that will be able to host those applications. But before it goes productive, we expect a few more years to pass. There is, from the Linux Foundation Energy, there is a project called CPAS that is looking into that. But also from the large vendors, Hitachi ABB has a solution already. I think GE is looking into that, and also Siemens is looking into those solutions. So they will probably come. They will first probably come as vendor lock solution, where you buy hardware and software together. And the next step, then through pressure from large energy companies, will be that there will be on general purpose servers that are capable of running real-time applications.
Okay, perfect. Thank you very much. Then we have a question from Davis with regards to protocols. Is this technology open to other substation protocols such as DNP3 or other open protocols?
Definitely yes. The reason behind this that it's independent from the software. So you can run a gateway software that is then able to speak those different protocols. So for example, if you need to convert IEC 61850 protocol into DNP3, you can look at the market, and there are a lot of vendors for this. The global players have it within their substation automation systems, but there are also other companies like Calcitech, for example. There's a company called iGrid. There is, I was talking to ETAP recently. They have one of those solutions. So converting protocols is not a problem. They can run on our platform without any issue. Usually you speak IEC 61850 within the substation, and then you go northbound with DNP3, or in Europe you would take IEC 104.
All right. Thank you very much. One question from Posha. I hope I pronounced that correctly. How do we connect hardware devices to your server? Maybe yours, I will take this one.
Perfect.
As we have a hardware platform which offers support for different types of interfaces, and the hypervisor who takes care of sharing the resources with the virtual machines, we can just connect the external devices to the interfaces this server offers. In general, this means we can use serial interfaces for that, but we can of course also bring USB ports to the virtual machines. And in fact, we see most of the connections using the Ethernet connections, which are already inside the system. But in general, as the driver support is very good for most of the hypervisors, we can also support almost every additional hardware card or extension card which can be provided using PCI Express. So the server itself provides already serial interfaces, USB and Ethernet, and we can extend it. We will have to look if the driver supports then already there for the specific application, but we can of course also add something like HSR and PRP and something like that.
Maybe in addition to that, so if you have specific needs for interfaces, please write email to Jan or me, and we'll answer that as soon as possible and find a solution for you. There should be a solution for nearly any of those problems.
Yeah, thank you. Okay, then another question. As we already talked a little bit about HSR and PRP, Jermaine asks, I read online that you support HSR and PRP. How do you do that?
I'll take that.
Okay.
So there are in general two possibilities. One possibility is that you run a software that supports PRP. HSR is a little bit complex, but we do it with hardware support. So we have extension cards that we can put in. So we have the possibility up to 8 interfaces. So it would be 4 redundant networks that we can connect at the same time. And those cards are using FPGA, which is very fast and accurate. So you can have them connected to a PRP network or HSR network, or if you have 2 cards or more than 2 cards, you can also connect them to HSR and PRP in general. The device then becomes a PRP node or a HSR node, and internally for your applications, it's just one interface. So your application see it as a normal Ethernet port, but within the substation network, there are PRP nodes. So it's more like a red box inside of the computer.
Yeah, thank you. Another question from Umer. I hope I pronounced that correctly. Sorry for mangling your name. Umer asks, do you supply software solutions to be installed on Windows-based PC for virtualization, and how is this application called? Maybe I'll take this one as well. So in fact, what we offer you is this hardware platform, and you decide what kind of hypervisor you want to run on that. If you want to run a Windows-based hypervisor, we can install you a Windows Server operating system on this machine. And the Windows Server operating system, in fact, already brings these virtualization features with it. There are a few licensing topics to be considered, but the Hyper-V from Windows is in fact a little bit a different approach than, for example, the VMware vSphere hypervisor, because it is a type 1 hypervisor, but it looks like a hosted hypervisor. So you install a Windows Server operating system and you add the role of Hyper-V. This is the name of the solution, in fact. This Hyper-V role then is installed as really this type 1 hypervisor with direct access to the hardware. But you start the computer, you can connect monitor and mouse and keyboard to the computer. You start this Hyper-V application really locally on the device if you want to, and you can manage all the virtual machines. So short answer is, what you might need here is Hyper-V based on Windows Server operating system. This is the name of the solution. If you want more information, please feel free to write us an email, or we will follow up afterwards. I think this would be the best approach. Okay, then let us check about the other questions. Osman wants to know which type of hypervisors does Velotech servers support except VMware and Hyper-V as we already described.
Should I take that?
Yes, please.
Okay. So I would say every modern hypervisor. So what we use is VMware and Hyper-V mainly. That's what we see mainly in the market. For real-time applications, I mentioned that before. We also did very extensive testing together with Wind River for the Helix platform. So this is also type 1 hypervisor, but it's a real-time hypervisor, so we can run real-time applications. So it would be suitable to run also protection and control if you have that software ready. So it would also work on that platform. And then there is, for example, open source hypervisor, which is called Proxmox, which is running very well on our device, which is also used from some of our customers. But if we are looking at utilities, what we see in the market is a lot of Hyper-V and a lot of VMware. If you have doubts of your hypervisor can run on the system, please get in contact with us and we can validate with our technical team. And in case we have not a validation yet, we can do one and approve it. Okay, thank you very much. And then we have a question which is kind of interesting because it pops up very often when you talk about virtualization. This is from an anonymous user. I don't know your name. If you want more information, please, again, just write us an email. The question is, in fact, very short. This anonymous user is asking, is this Docker? I guess this is more the question if we are virtualizing the application or the machine. Okay, let me take that. So it's not Docker, because this is a virtual machine. So we really take a Windows operating system or a Linux operating system and then an application running on it, like a typical substation automation system that you run, and you have a look and feel of a normal computer. But if you are taking a Linux operating system or even a newer Windows 10 version, you can also run a containerized environment and you can run Docker container on top of it. In addition to that, if you use container or Docker, you probably don't need virtualization. So we're not talking, there's one customer in substation automation that is using containerized applications for the applications, but mainly we are here with virtual machines still. Containerization is, let's call it the hype of the last few years from the IT world, coming from the cloud computing environments and running on computers and systems, which separates applications in microservices, which is scaling perfectly and allows you to run those applications easily in complex infrastructures. We believe that within the next few years, most of the applications also in substations, at least for newer installations, will be containerized, so will be Docker. But at the moment, it's still, the way from bare metal installations, single boxes, into virtualization and having multiple applications on one hardware using a hypervisor.
Okay, thank you very much. Then a question from Juan. Do I have to store the virtual machines on the hypervisor, or can they be placed somewhere else? I can take this one.
Perfect.
So as we said before, a virtual machine is in fact really a set of files describing the virtual machine's configuration and containing the virtual machine's data. Meaning the hypervisor really doesn't care where this file is placed. It can also be placed on a storage system outside of this host system, for example, on a storage system which is able to build up a huge RAID containing of large number of disks. So this is in fact possible, and we saw that very often in the past. But there's one point. You are really then, the performance of your virtual machine is then really depending on the storage system's speed and also on the connection of the storing system to the hypervisor or the host system. Meaning, if you have heavy load, for example, you have a nice iSCSI connection to your storage, you have heavy load on this network, then the performance of your virtual machines may decrease. So this is a little bit of decision if you want to really store the data on the host system itself and apply backup, proper backup system, or if you want to place it somewhere else where you consider it to be safer. What we see now with the implementation of, for example, RAID system or a RAID in our RSA PC for this virtual machine data, most of the customers choose to place the virtual machine data on the device itself, because with the RAID, we have the security, the data security, because it is redundantly stored, and we do not lack any performance. This is in fact the most important point. I hope this answers your question. Possible, yes, but in fact, we do not see it very often anymore. Okay, then let's check about new questions. Here is one from Marcos. Marcos wants to know, do you think virtualization is more economic than hardware?
Yes. Definitely. There are three reasons for this. You save CapEx cost, because installations will be cheaper, because you have less hardware, you need to have less installations and so on. The second one is you save operating cost, because virtualized appliances is much easier to operate and to maintain. When I look back on our own IT infrastructure within our company, and we discussed virtualization 10 years or 15 years ago. So for our servers, for our ERP system, there was no question to take it, because it's more or easier to manage from the OpEx perspective. So you save a lot of operation cost. Then one thing that is also cost related is it's increasing reliability. So Virtualization makes it much easier to have your uptime of your application managed. It makes it easier because you have less different types of hardware. You have a similar structure in case you need to replace something. You have always the same thing, and you can probably do it by software. In case something fails, you can just start it somewhere else, or it will be done automatically. So those three things are clear. It reduces CapEx, it reduces OpEx, and it increases reliability.
Perfect, thank you. We are running a little bit out of time. Maybe two last questions to answer. As you said before, please feel free to contact us via email in case of further questions, and we will of course also follow up afterwards via email for the questions we didn't manage to answer now. So two questions, in fact. Maria wants to know, what are the power supply options you have, as they have a special requirement for 110 volt DC. And maybe a second question, which is a good conclusion, or the answer might be a good conclusion for today. Hanno wants to know where he can get more information about this hardware platform.
Perfect. Let's start with the first one. So we have three different power options. They're hot swappable, so I can replace them during operation, and we have redundant power supplies. So you can imagine that you have some kind of brick on the back that you can just pull out and replace it with another one. And there are two of those, and in case one fails or one is replaced, the other one takes over, and the system is full operational. There is an AC power supply that is covering all the AC range from well, 90 to 260 volt AC. Then we have a DC power supply, which is covering from 16 volt DC up to 160 volt DC. So this will meet your 110 volt DC. And then we have a high voltage DC power supply, which is covering the DC power range from 110 volt DC, 120 volt DC to 220 volt DC. So also covering the 220 volt DC. And this third power option also covers AC as well. So it would also work for AC networks. You find those specs on our webpage on buildtech.com, or just Google RSA PC, and you will come to our webpage and directly find those information. If you need further information, you will get a recording afterwards and to all participants, and there we also send a link with the information to the product itself, so where you can then download datasheet, brochure, and see the specs. In case there are open questions, always please feel free to get in contact with us. You're more than welcome to write us email or just give us a call, or whatever you like. In case you have a project, we can also make a session with you only, and then really discuss your specific questions and see if we can work together and find a solution for you. Great. So I think that was the last questions. All the others we'll answer afterwards. Jan, thank you very much for taking this time. Dear everybody, thanks a lot, and I wish you a nice day for all those from North America and South America market. And from Europe, well, good evening, and from Southeast Asia, good night. Thanks a lot, and talk to you soon. Bye-bye.